All right, when we're doing our long division, we're seeing how many times this first piece goes into each of these digits over here. Well, we know 23 doesn't go into 4 because it absolutely does not fit, but 23 can go into 42. How many times can 23 go into 42? Once. So we put a 1 up there. Take the 1 and multiply the 23 and put it underneath. Then we subtract the 2. 42 minus 23 is going to leave us with 19. And then the 7 drops down. So like super old school, looking at this long division style. And this one's a little bit harder to spot, because we did do it right. It is a 1 in the front, but 23 into 197 is a little bit harder to spot. 23 actually goes in 8 times. Because 8 times 23 is 184. So when we subtract those lines, we're left with 13. And at this point, we have options, because we could put a decimal point and a 0 and keep going and do it in a decimal form. Or we can write this as a mixed number, where we take our 18, which is the number on the top, and write our remainder as a fraction. So we wind up with our remainder of 13 over the thing we divided by, 23. Thank you, sir. So we're going to be working with long division today. It's not just going to be numbers. It's going to be back in how we did it in December. So we've done this before, but it was last semester. So some of you guys did this with Ms. Jane. Some of you guys did this last year. But we're going to do a little bit of long division today, because that's how we will change between forms with our rational stuff. So it is something that's going to come up. I'm not just going to give you this to torture you. There's reasons, I promise. So the problems that we're going to do today, we're going to do half the problems on the worksheet, and then I'm going to give you guys the other half of the worksheet to do as homework and practice. So we're going to do 4 of them today. So the first problem on the homework looks like this. Oh, except it should be, that is number 1 on that worksheet. Oh, it's because I changed my mind. I crossed it out. Yeah, the bell work. Well, that's just the end of the bell work. Yeah, we had a different activity for the long division review, but since long division was actually last semester, I wanted us to do a little bit more in depth than me just giving you another puzzle thing. So this is our first one here. And we can do this in a couple of different ways. One of the ways that we can do our division, and we talked about this last semester, is when we are dividing by a monomial, by a single piece. We did this back in the days of polynomials. What we can do is we can take this and cut it into pieces and simplify each piece. So when we're dividing by a monomial, our life is actually easier, because all we need to do is to take each chunk and set it up as its own little baby fraction. So our 2v cubed over 4v plus v squared over 4v plus 3v over 4, that's meant to be v. So we can reset this up like this. It's like distribution. We're taking our 2v cubed and dividing it by 4v. We're taking our v squared and dividing it by 4v. And we're taking our 3v and dividing it by 4v. So if we just have a monomial over here, a single term, no adding or subtracting, we can do it this way. It's not going to be super common for us to see that coming up, but this is the easiest of the divisions, so I want to just remember how to do it. Because then what we're going to do is we're going to come into each fraction individually and simplify it. So if I have 2v cubed over v, and I'm just simplifying this chunk, how can I simplify this? So I'm with you on that the v cancels out with one of the v's in the exponent, leaving us with a v squared. Closer. So we still have our v squared on top, and we've noticed that the 2 and the 4 both divide by 2. So that divides by 2, and that divides by 2. This turns into a 1, and that's over 2. So we actually wind up with v squared over 2. So it's a simplifying thing. 2 over 4 is the same as 1/2. You could also put 1/2 v squared. That is also fine. Why are you doing that? There we go. Thank you. Then we're going to look at our next one. If we have v squared over 4v, what's going to happen? Yeah. So I've got a v on the top and a v on the bottom. So one of my v's is going to cancel out. So we're going to wind up with v over 4. And how about that last term? What happens? What happens with the 3v over 4v? 3 over 4. The v's cancel out. So it's just like our simplifying stuff when we would do it with our rational functions. It has to match top and bottom, and we can cancel it out. I can cancel out numbers. I can cancel out letters. What's up? Yes. Oh, Milani, you also want to go, didn't you? So that's our answer on this one. Questions on this one? Okay, the next one we're going to do is number 3. This one is going to take us through the long division. So for this one, we're going to have to set this up as our long division, which means I'm going to rewrite this whole thing. Just like the one in the bell work, where we have our big division house, and we have our what's inside being the x cubed minus 12x squared plus 29x plus 31. And we're dividing all of that by x minus 8. So this is how we're going to set it up. When we're doing our long division with polynomials, just like when we did with the numbers in the bell work, we're seeing how many times this piece goes into my first part, and then my second part, and then my third part, and we do it in stages. And what we're going to do is we're going to look at the first term of what we're dividing by, so my x, and I want to look at x cubed. So I want to know x cubed divided by x, and we put that up top. So we can set it up, those of you that had me last semester, we set these up as little baby fractions a lot, where I would take the first term of my divisor and the first term of my dividend and set them up over here. What is x cubed divided by x? X squared. That's what's going to go up on top. X squared. Then just like we did with our bell work with the whole numbers, we take what's on top times everything on the side. So we're going to take this x squared times this whole x minus 8 piece and write it underneath. So we're going to have our x cubed minus 8x squared. Then, just like in the bell work, we subtract. X cubed minus x cubed gives us 0x cubes. That's what we want. That first term should always cancel out. And then we have negative 12x squared minus negative 8x squared. That's going to give us negative 4x squared. And then I'm going to drop everybody else down. They just fall. Questions on this first one? That was the first round of it. We have at least 2 more to go. Oh, yep.
8x and then 12. Is that minus sign like that the curve?
We have to subtract this whole line. So it's negative 12 minus negative 8. So we get a double negative situation going on there. Then we basically start the whole cycle over again, except now this is my first term, my minus 4x squared. Yes, dear?
How do you get negative 4 from negative 12 and negative 8?
Negative 12 minus negative 8. We have to subtract.
Wouldn't that be negative 20?
That would be if we added, because negative 12 plus negative 8 would give me negative 20. Negative 12 minus negative 8 is the same thing as negative 12 plus 8. Because those two negatives cancel out there. Okay? Cool. Good question. All right, so we're going to start that whole process over, but now I'm using my first term in my divisor and my first term down here. So just like I did over here, we have minus 4x squared divided by x. What do we get when we divide minus 4x squared by x? Negative 4x, exactly right. So that's our next term on the top is negative 4x. Just like we did with the purple piece, we're going to take this and multiply it by the whole term and put it down underneath over here. So 4x, or negative 4x times x gives us negative 4x squared. And negative 4x times negative 8 gives us a positive 32x. And what we need to do is we need to subtract everything there. And we're going to be really careful with signs. Got my negative 4x squared minus negative 4x squared. So that double negative comes into play again, and we wind up with 0 x squared, which is what we want. This first term should always zero out. And then we have our 29x minus 32x, which is going to give us negative 3x. And then we're going to drop down our plus 31. And we get to do one more round of this. We're going to do the whole same process again, but now with this as my first term, my minus 3x. And we're going to divide it by x. So if I have minus 3x and we divide by x, what do we get? Negative 3. Negative 3. So just like the last two rounds, I'm going to take this negative 3 times my whole term over here and put it way underneath. So negative 3 times x gives me negative 3x, and negative 3 times negative 8 gives me 24. Same vibe though, we gotta now come through and subtract. When we subtract, we get 0 x's. So we're subtracting everybody here. And we have 31 minus 24, which gives us 7. So we have a remainder of 7 because I can't divide again. I can't take 7 and divide it by x. So our answer, what our answer is going to be whatever's on top up here, and then we're going to build a fraction out of our remainder and what we divided by, just like how we did over on the bell work to get our fraction here. We can do the same thing over here. So we're going to take our remainder, which is 7, and put it over what we divided by, x minus 8. So this is our full answer. Questions on this one? Okay, for the most part, when we're working with these in this chapter, they're not going to be this long. This is the longest it will ever be for us. Just because I wanted us to remember how to do our long division, but we're going to have problems that look a lot more like this for number 5 and number 7. The last two that we do are going to be a lot more like what we're going to continue doing next week, because we will be using these again. So our clue on this one is in our instructions. Our instructions tell us to simplify and then divide. So our simplify, that's our factoring. So we're going to factor this and see if something's going to cancel out. Because I don't want to have to divide a quadratic by a quadratic. That's super gross. But let's see if we can rewrite this in factored form and simplify it a bit. So this is number 5. So I'm going to look at my numerator here. I don't have an a value, so I can just use my frame. I need a pair of numbers that multiplies to be 3 and adds to be 4.
31.
3 and 1. So our factors here are x plus 3 and x plus 1. We do the same thing on the denominator, where I'm going to take my x frame, a times c at the top, which is -3, b on the bottom is +2. We need a pair of numbers that multiply to make -3 and adds to make +2. Three and -1. So I can write this in its factored form as x plus 3, x minus 1. And we can see here that our instructions actually did give us a big clue here, because I can simplify this. What cancels out? The x plus 3's. So we're really just looking at x plus 1 over x minus 1. This is what we need to divide, and we are going to divide it. So we're going to set this up as a long division, where we have our x plus 1 being divided by x minus 1. We do this just like the ones we did before, where I take my first term and we set them up as their own little baby division. What is x divided by x? Which means it equals, does not equal 0. 1. It equals 1. So we can put a 1 on top up here. Then we're going to multiply this 1 times this term and put it underneath. 1x minus 1. And we're going to come through and subtract both of these pieces. So our x minus x gives us 0 x's. That cancels out. That's the whole point. And then we have 1 minus -1. 1 minus -1, which is 2. This is plus 2. 2 is not going to divide by x anymore, so we're going to write this as a mixed number like we did before. So our what's on top is our 1. So I'm just talking in general. So when we're setting up our remainder, we have what's left over on top, that 2, and what we divided by underneath, x minus 1. So we have the statement of 1 plus 2 over x minus 1. That almost looks like the equations we worked with yesterday. If I take this and flip-flop them, so that I'm going to write it big and at the bottom, 2 over x minus 1 plus 1. Do we not now have our, oops, that was not the laser, our A, H, and K form? So we're using our long division, and we're going to use it a lot next week. Okay? So this is not me just pulling something out randomly to torture you. It's tying in. We're going to do one more, and then you guys will have the rest of the time to work on that worksheet and practice this. Because we have done it, but it has been several months. So this one is also in the simplify and divide section, but it doesn't have anything we can simplify. It's just got that short division. So we've got our x plus 4 over x plus 2. So on this one, we are actually just going to hop straight into our long division. Since I don't have any squares in here, And these two pieces don't match. I know we can't simplify. So we're going to go straight into our long division where we're going to divide x plus 4 by x plus 2. We're going to look at our first terms. And we're going to set that up as our little baby division. We've got x over x, which simplifies down to be what? 1. We take our 1 times our whole term and make it 1 times x plus 2, or x plus 2. And then we need to subtract that whole line. So we've got our x minus x, which is 0 x's. And we've got our 4 minus 2, which gives us a plus 2. We wound up with the exact same equation. That's ridiculous. Because then we're going to write this in our mixed number format. I will always make a pit stop at this mixed number stop, because otherwise I get things mixed up and confused in the wrong place. Because we have our remainder of 2 over what we divided by, x plus 2. And this is 1 plus our fraction here. So come Monday, we're going to be taking these and we're going to be switching these around so that they say 2 over x plus 2 plus 1. Okay? So the long division ones at the top are probably a little bit more familiar. We focused on that style in the fall. But the ones at the bottom half are exactly what we're going to be using them for next week. So what you guys have is you have 10 minutes where you can work through the rest of them, or at least most of them, and then you'll only have 1 or 2 problems to do over the weekend. On Monday, we're going to take problems like we have here, switch them into the other form, and then graph them. So all that graphing stuff's still going to hang around. Okay? But I'm going to give you the last, 10 minutes to work on that. So finish this review worksheet. And then, yeah, do the thing. It's Friday. And I'm tired.